All right, so in this section, we're going to start talking about the idea of divisibility. It's a very important concept in mathematics, and it's kind of how numbers are built up. We'll talk about how divisibility kind of allows us to explore the building blocks of numbers through prime numbers. But before we talk about anything in particular, I do just want to talk about some language and notation. And before that, I just want to say, so I don't have to keep writing it, in this section, unless I specify otherwise, all variables here stand for numbers, and they are going to be elements of the whole numbers. So when I say a equals b times c, I'm thinking of some whole numbers now. Okay, so whenever I introduce a variable, we're thinking of it standing for whole numbers. Okay, so now some notation. Let's say we have a whole number a, and it equals b times c. I can write a as b times c. For example, down here, 21 is 7 times 3. So, just some language. We'll say that the numbers that you can multiply together to get a, we'll call them factors of a. So we'll say b and c are factors of a. Or another way to express it, a synonym, is b and c divide a. So b divides a, c divides a. So that's another way to express it. And they're going to be kind of the language that we're going to use the most. And because we just don't want to write is a factor of or divides over and over again, just because it takes time and it takes room off your page, mathematicians like to use this symbol, which is just a straight line. So this symbol here means that b is a factor of a, or b divides a. And as an example here, well, 21 is 7 times 3. 7 divides 21. 7 is a factor of 21. So is 3. 3 is a factor of 21. But is 21 a factor of 7? Well, no, it's not. I can't multiply 21 times some other whole number to get 7. So 21 isn't a factor of 7. It's a multiple, but it's not a factor. So to say that, we just put a little, of course, in mathematics, we always do this to say it's not something, we just put a little cross through it. So they say 21 isn't a factor of 7, we'll put a little cross through it. And kind of the opposite language, if we're talking about factors, we can also talk about multiples. If a equals b times c, well, we can say that a is a multiple of b, and it's also a multiple of c. Or we could say, in divisibility language, a is divisible by b, or divisible by c. So, in the example here, 21 is a multiple of 7. 7 times 3 is 21. 21 is a multiple of 3. 3 times 7 is 21. So that's how the language works. And we're going to really focus on this notation here. Remember, think of this little straight line here, straight vertical line, as meaning is a factor of. I do want to make one note here. I want to say that, well, if we write a is a factor of b, well, that means that b equals a times some number. We don't know anything about the other number per se. So b equals a times c for some whole number c. That's going to be important. And what about if it doesn't? If a doesn't divide b, if a isn't a factor of b, then it's going to have a remainder, right? Because you can imagine, I'll just do this up here, something along the lines of, let's do 4 and 11. So 11 isn't divisible by 4. 11 isn't a multiple of 4. And if you remember the quotient remainder theorem from a few videos ago, I can write any number as the largest multiple of the divisor that I can pull out of it plus a remainder. So I can write this as 4 times 2 plus a remainder of 3. So this is our remainder. And remember, if it's a remainder, well, if it doesn't divide, the remainder can't be 0. And it can't be, in this case, 4 or bigger, because then you could make another group. So if we're saying that A isn't a factor of B, that means we can write B, I'll do this in black, B, as A times C, so the biggest multiple of A we can pull out of B, but there's going to be some remainder. So plus a remainder R, and I need to tell you about R. Well, let's say for some C and R that are whole numbers, but I need to tell you a little bit more about R. And R, well, it can't be 0, because if it was 0, it would A would be a factor of B, so it needs to be greater than 0. But it has to be less than A, because we pulled out the biggest multiple of A. This is a proper remainder. So if you're grouping things in groups of size A, this has to be less than A since it's a remainder. All right, so I just want to talk about some special cases for divisibility. So remember, A is going to stand for any whole number you like. So the first one here says that every whole number is a factor of itself. And of course that's true, right? You can always write A as A times 1 for any A you like, any whole number you like. So every whole number is always a factor of itself. If you want, here's an example. 17, you can write as 17 times 1. That's fine. 1 is a factor of every number, because you can always write, it's basically the reverse statement of what's going on here. So look here. 1 is a factor of every number because I can write any number I like as A times 1. So 1 is always a factor of A because I can always write it as A times 1. Except for the case when A is 1, well, nothing else is a factor of 1, right? The only things that you can multiply together to get 1, the only whole numbers, are 1 times itself. So the only factors of 1, or sorry, I should say the only factor of 1 is itself. So no whole number besides 1 is a factor. So if A doesn't equal 1, if it's some other whole number, then it's not a factor. That's what this symbol here means, not a factor of 1. So we dealt with the special case of 1 in some sense. 1 is a factor of everything. Nothing but itself is a factor of 1. And 0 kind of behaves the exact opposite. Everything is a factor of 0. Well, what can I multiply A by to get 0? Well, that's pretty easy. I can multiply anything by 0 to get 0. So A is a factor of 0, since I can write 0 as A times 0. And the other way around, 0 is never the factor of any number except 0. So every time I multiply a number by 0, I always get 0. So unless A is 0, there's no way I can go 0 times something to get A. So 0 is not a factor of any non-zero whole number, any natural number. So they're kind of the special cases. Think of it as 1's always a factor and 0's never a factor. That's a good way to remember it. But I think it's pretty intuitive if you understand what it means to be a factor.